Hello, I'm Adam Price, the Vice President of PNT Simulation here at Spirent Communications. Over the last decade, PNT, position, navigation and timing, has become more and more important to many parts of our lives and many industries. Our customers, who are the receiver developers and the system integrators into the PNT ecosystem, need to be sure that what they are developing is meeting the needs of the markets and the customers that they are providing this equipment to. Because PNT is now becoming more sophisticated, more signals, more complexity, more vulnerabilities, more attacks, our customers need to test and assure that their equipment is robust and resilient. That is why here at Spirent we have developed PNT X. PNT X is the industry's most powerful PNT simulator. We've put more processing power, more signals, more capability into a footprint unrivaled in the marketplace, and we feel very proud that this will deliver to our customers one of the most significant step changes in test capability that the industry has seen.
Hello, my name's Mark Holbrow. I'm the Vice President of Product Development for Spirent's Positioning Technology business, and I'm really proud to be sitting here today to talk about the new PNT X simulation platform. The need to improve and enhance realism from a simulator perspective is really paramount to us. The opportunity through this system to add that realism comes from a number of different angles. There is the opportunity now for different signal structures to be synthesized and simulated via separate offline IQ files. Those IQ files can then be fed into the system to enable the customer the realism of being able to have different threat scenarios and different threat signatures to be able to emulate the real world as best as possible. In other examples would be building the opportunity now for having the ability to bring in different maps and different topography. So as a vehicle is moving inside that environment, the appropriate multipath, obscuration effects are all being applied to the signals. Again, taking us that step closer such that it's nearly as close as possible to the real world back in the lab environment. With the PNT X system, the ability and the capacity to be able to expand to fulfill all of the signals of space, all of the signals of opportunity which are out there is a really pressing need. Whether they be LEO, whether they be GNSS, whether they be ground transmitters, all of those activities and all of those signals need to be simulated to again provide the realism that's needed for the test applications that our customers require. Further to that, the opportunity as different evolving signals and different ICDs as they start to come to fruition, the customers that we have need to know how those different signals are going to be affecting their designs, and to be able to get ahead of the game. We can do that through the flexible capabilities that we've got, which enable the user to define and control different signals themselves. The assurance that the signals that you want to be simulated are actually simulated time after time after time, identically with the same fidelity and the same performance, is an absolute primary need of any test application. To meet that ever increasing and changing landscape needed us to build upon the heritage of our current platforms to develop the PNT X system.
My name is Ricardo Verdeguer, and I am the product manager of Spirent PNT X. I am very excited to present what is the result of an innovation process that has been refined and improved for over 40 years. In the 1980s, we successfully launched the first GPS simulation platform. Today, we can proudly announce that PNT X is the 6th generation of Spirent's commitment to advancing PNT technologies. At Spirent, we understand that the increasing diversity and criticality of PNT applications means that test coverage and simulation realism cannot be compromised. Also, in the recent years, we've seen how NAVWAR has evolved, demanding higher protection for our PNT systems in the harshest RF environments. PNT X is a revolutionary simulation system that addresses the increasing complexity of the PNT environment, all with a simplified, all-in-one solution that can generate GNSS, RF threads, and a wide variety of sensors and signals of opportunity. Let's take a closer look. PNT X integrates a diverse technology stack that leverages the right technology for every application. It incorporates the industry-proven, purpose-designed, FPGA-based SDR architecture that is mainly used for high-precision GNSS signal generation, as well as GPUs that are leveraged in a targeted manner for specific software tasks. The inherent flexibility of the platform offers infinite scalability for the solution, allowing seamless control of multiple signal generators within a unified system orchestrated by a single simulation scenario. Thanks to the powerful engine and enhanced signal capacity of the PNT X, users can reduce lab footprint while maintaining the ultimate fidelity. Usability, interoperability, performance, and scalability. These are the core values that have driven PNT X development since its inception. Today, it would be impossible for me to cover everything that PNT X has to offer. Instead, I'll present 4 new features that make PNT X the most powerful, most capable, and most realistic PNT test platform in the industry. And I'll do that by presenting 2 different use cases, the first of them being NAVWAR testing. So for NAVWAR testing, I want to show you 2 new features that we have introduced. The first one is 3D terrain modeling. So we have indeed included an embedded real-time 3D visualization tool that provides visual feedback while the scenario is running, as well as 3D information of the surroundings. Our aim is to transform our customers' lab into real-world test ranges. And for that, we are allowing users to import realistic 3D maps and navigate through them with their simulated vehicles. With PNT X, there will be a set of maps, including different cities and landscapes around the world, included by default in the software offering. But it's not only about visualization. We wanted to go one step further, and we are also including the possibility to calculate obscuration and multipath effects based on the 3D maps loaded. And we are doing this for all the constellations, all the GNSS constellations supported, and frequencies. That means that we will also support other cases like jammers and spoofers. In essence, or in summary, we will support this capability for every RF signal that we natively generate in the simulator. The second feature that I would like to speak about is the IQ Spatial Awareness. This is a Spirent patented solution. In the recent years, we've seen how IQ-defined transmitters have become a rapid and effective way to simulate interference and novel PNT signals without our involvement in the signal definition phase. However, this approach has sometimes failed to model the inherent characteristics of dynamic scenarios, since IQ data is pre-recorded and may not account for the relative position and movement between transmitters and DUTs. To solve that problem, we have come up with this solution, the IQ Spatial Awareness. This capability takes into account the transmitter to receiver relative motion and superimposes signal effects such as power levels, signal delays, and Doppler offsets onto the IQ data. Consequently, the same IQ file can now define different transmitters, also across different scenarios, as simulation software will generate the associated RF signal effects. This solution enhances the realism of IQ-defined transmitters and can be used together with the 3D obscuration and multipath feature to simulate rich RF environments. And now we are going to jump into the second use case, which is beyond GNSS. And this is a way for us to future-proof our platform and make sure that we can meet all the current and future needs of our customers. So in this regard, I would like to first introduce our LEO PNT and PNT for LEO capabilities. LEO has been a hot topic in the last few years, and we've made sure that we have a realistic simulation offering in the PNT X. First of all, on the first part, we are making sure that we have realistic LEO orbital models inbuilt that take into account complex gravitational effects and LEO satellite parameters such as drag coefficient, mass, and cross-section area. And we are taking those LEO orbital models to model full constellations, but also to model single satellite vehicles so we can test GNSS in LEO orbits. On the signal generation part, we have our solution for sonar pulsar signal generation. This is the only sonar certified solution in the market and is our first attempt to demonstrate how the PNT X can actually support LEO constellation testing. And also this includes demonstration and production ICDs for sonar pulsar signals. But for those customers that want to go one step further and want to test with new or want to create their own LEO constellations, we also have the possibility to broadcast custom signals. And we do that by either injecting IQ data with SIMIQ or by controlling the low-level parameters of the signals, such as chip rate or the binary offset carrier of the signals, as well as the navigation data via Flex. But it's not only about LEO. We know that beyond L-band, there are other frequencies that are currently being used for PNT signals. And one of them that we have incorporated into our simulation offering is S-band. So we have introduced new internal app converters that are suitable for S-band frequencies. This allows the PNT X to generate native RF for regional GNSS and LEO S-band constellations. Also, we have introduced this feature looking at future applications such as lunar PNT. These app converters will be compatible with all our software suite, and therefore they will be compatible with IQ Replay supporting static and dynamic IQ-based transmitters, also enhanced with IQ Spatial Awareness. Thank you all for listening to us today. I hope you found this presentation insightful. And just two last things from me. First of all, PNT X is already available for purchase. And second, please go to spirent.com if you want more information about the system. Thank you and have a good day.